We're going to present this problem with my teammates Max, Andres, and Jose Arturo, and Max will tell you the first.
Okay, the problem says a particle is moving in a straight line, so its position function is s for t equals to this function.
Well, the problem says we have to calculate the derivative of the position function using the limit definition.
The point B says calculate the x-intercept and the y-intercept of the position function. Also, you need to graph it and explain it. We will show you.
Then you have to calculate the tangent line equation at the point p0 minus 6.
Then we have to calculate the velocity of the point of the particle after 2 seconds.
Now, after you made the derivatives, it will, point E says when will the particle stop at the time? At the time enters at 0.2. That means between 0, 2. So now we need to calculate the derivative of this function, but first you need to substitute the derivative formula, which is this, and in every t of the function you need to substitute t plus h. So as you can see right here, we expand using these formulas, and this is what we got after we expand all these. After that, you need to put all these in order using the 4 steps formula, and you can see it's in order. First is the t's, and then the t squared h, and then th, and then h squared, and after all h, and then the regular number. After that, you need to do this step, which is with the minus sign. So what is here? You need to eliminate with the function. As you can see, if you put a negative sign, everything is going to eliminate. It's going to eliminate this one, with this one, with that, with this one, and this one, with this one, and this one, with this one.
And when you finish eliminating, you're gonna get only this, and this is what you're gonna use to get the derivative. So first you have to isolate the h, and by doing this you're gonna eliminate every h that is in here. So you're gonna get this. So after doing this, we have the limit says that h is equal to 0. So we have to replace all the h to 0, and some values will be 0 because you are multiplying them for 0, and 0 multiplying by 0 is 0. The derivative is 3t squared minus 12t plus 11.
Well, the point B says we have to calculate the x in the y-intercept. So with the derivative we got in point A, now the only thing we have to do is substitute the t with 0 in each one of these, in this, and this. So 0, every number that multiply 0 is equal to 0. So the result is going to be 11. For the y-intercept, it's going to be 11. Get the x-intercept with the same derivative, we have to use the general formula. So we have to substitute the values here with these numbers here. So when you resolve the general formula, these are going to be the x-intercepts, which are 2.57 and 1.42.
The point C is asking us to calculate the tangent equation at the point 0, minus 6. So for this we have to use the slope formula, and we have to get rid of y. You have to replace the values x1 and y1, and you're gonna get something like this, and then you resolve it, and the result is gonna be the tangent equation at this point.
In point D, we need to calculate the velocity of the particle after 2 seconds. Well, now this is the function we got from the derivate, and after that we're gonna substitute in every t 2, because it's the time they're giving us. So after you substitute this, you multiply 2 times 2 squared is 4. So 3 times 4 is 12. Minus 12 times 2 is minus 24 plus 11. So if you add these, you get 23 minus 24, which is equal to negative 1 minus 1. This is going to be your answer.
E asks us when will the particle stop at the time interval 0,2.
So we graph it to see which are the points, and we conclude that 1, 0 and 2, 0 are the points that the particle will stop at this time interval.
When I met you in the summer, to my heartbeat sound,